The vertical asymptotes. So we were seeing I was drawing these vertical lines throughout our graphs to show you where we stopped having function values. Those points are called vertical asymptotes. So the vertical asymptote of a rational function, f of x, which is p of x over q of x, are found by determining the zeros of q of x that are not zeros of p of x. If p and x and q or x are polynomials with no common factors other than their constants, we need to determine only the zeros of the denominator. So what this is telling me is that finding domain just required that I just find the zeros of my numerator. Here I need to find the zeros of my numerator and denominator. I think I misspoke for a second. So to find your domain, we just need to find zeros of the denominator. For vertical asymptotes, we need to find zeros of the numerator and denominator and make sure that they do not share a zero, because if they share a zero, we get a whole, not a vertical asymptote. So if a is a zero of the denominator but not the numerator, then we have a line called that we label x equals a is a vertical asymptote of the graph of the function. And this is a line that we cannot cross. When there's a vertical asymptote, that means we cannot have a function value there at all. We cannot cross that point. It's going to be a little different than what a horizontal asymptote is. Holes, the holes of a rational function, are found by determining the zeros of the denominator in the numerator again, so q and p. If x equals c is a zero of both p of x and q of x, and then the graph of the function has a hole at x equals c. So we're going to determine the vertical asymptotes of this function. So 2x minus 3 and x squared minus 4. So we're going to look at the zeros of the denominator first. So we're going to take x squared minus 4, set it equal to 0. And what we're going to see if we solve this is that x is going to be plus or minus 4. We have two zeros, negative 4 and plus 4. So these are our possible locations of asymptotes. So my possible asymptotes are going to be x equals 4 or x equals negative 4. Sorry, negative 4 first and then 4. And then I would have to find zeros of the numerator. So if I do set that equal to 0, I solve for x, this is the 0 I get. So what this means is this 0 is not the same as either of those. This is not the same. That means that these are now officially vertical asymptotes. This means if we were to graph this, I'm going to be 100% sure what's going on here, but definitely, we'll see our actual graph of it. We should be finding that we would have these asymptotes here, a point we don't cross. Let's actually see what this graph looks like. So this is what your graph would look like. I made a typo, just a second. If I solve this, this should give me plus or minus 2, which are my vertical asymptotes. I'm grading too many tests before doing this. These would be your vertical asymptotes. So my vertical asymptotes would be x is negative 2 and x is 2. And still the bottom have that asymptote of 3.5. It doesn't match. So these are vertical asymptotes. You see the blue line is your graph. The green lines are your asymptotes. So we come here, we get to that -2, and what happens is your graph will shoot off towards negative infinity or infinity. Here it's infinity, here it's negative infinity. The same thing on these sides of this one. So we see that we have these 2 points and -2 and 2 that I can't cross. So I can't have x values there. So here we have f of x is x squared minus 4x over x cubed minus x. So you see the graph here, there's something missing from this graph, which we're going to point out here in a minute. So if I take the denominator and I look for my zeros, so I can factor this, and I have x squared minus 1 equals 0, x minus 1, x plus 1, because we have a difference of squares. So this x cubed minus x factors into x times x minus 1 times x plus 1. So the zeros would be 0, -1, +1. So my possible vertical asymptotes, we're just going to call them V asymptotes, are going to be x equals 0, x equals -1, or x equals 1. So one of these is not an asymptote. You may have noticed looking over here which one it is. We see -1, we see 1, we don't see 0. So the reason we don't see 0 is because now if we look at the top, we set that equal to 0. I can factor out an x, and then I have x minus 4 equals 0. So here my zeros would be 0 and 4. So because there is a 0 here and here, that causes there to be no asymptote there. It's kind of like those zeros cancel each other out, but that's not exactly what happens. Because if you remember, 0 divided by 0 is still undefined. So what we're getting here is that if we had picked a point, f of 0, we would have 0 divided by 0 once we plugged in the zeros here. That is still undefined. So in a way, it kind of cancels itself out and it doesn't leave an asymptote, but what it does do is it leaves a hole. So there's actually like an open point right there. So my vertical asymptotes are x equals -1 and x equals 1, and then I have a hole at x equals 0. Okay, so this is the graph in Desmos. So if you notice, if I hit at x equals 0, it tells me it's undefined. So that's what we mean by a hole. And sometimes a lot of graphing technology will not show you that we actually have a hole in that spot. So there should be like an empty spot like this. So there is a hole there, and then we have the two asymptotes and -1 and 1. So for number 7 on your worksheet, A, B, and C, what we're looking for is whether we have, well, if we do have vertical asymptotes and if we do have holes. So we're not always guaranteed to have holes in vertical asymptotes. Sometimes you might have one, sometimes you might have the other, sometimes you might have neither. But go ahead and see if you can find them for these for these 3 functions. Okay, so without any graphs here, we'll make a little spot off to the side. So we're not going to have any help other than some algebra skills here to figure this out. Sorry, I was trying to move something out of my way here. Let me try that one more time. There we go. So for A, we look at the bottom and we set that equal to 0. My possible vertical asymptotes, we said we have to FOIL this or factor this, sorry. This should factor into x plus 4, x minus 3, because they multiply to give me negative 12, but add to give me a positive 1. So I would say that I need to look at the points negative 3 and 4. These are possible vertical asymptotes. So just call them VAs for right now. Second, we have to look at that numerator and see if it shares with that numerator as well. So my numerator is x squared minus 16, which you can do factoring if you wanted to. You can solve for 16. It's a difference of squares, so it'd be x plus 4, x minus 4. So my zeros would be negative 4 and 4. So once again, we both are sharing this 4. So these are my possible vertical asymptotes. What it tells me is I only have one vertical asymptote. My vertical asymptote is going to be x is equal to negative 3. And once we're done here, we can put these all in decimals and we can see where if we have these asymptotes correct. B, just do a similar thing. So the denominator is 2x squared plus 5x plus 4 equals 0. We will find zeros at the bottom. Well, we could factor that into x plus 1, x plus 4, because multiply those together, you get 4, add them, you get 5. So I end up with x could be negative 1 or negative 4. That's the zeros at the bottom. So these are my possible vertical asymptotes. Next, we look at the bottom, x minus 1 equals 0. Well, that would solve into x is equal to 1. So we do not get the same 0 on the top and bottom. We got negative 1 and 1. So that means that I have two vertical asymptotes. My vertical asymptotes are going to be x is equal to negative 1 and x is equal to negative 4. And then for this very last one, if we look at the denominator, we got x squared plus 25. So we're looking for zeros that are going to be real numbers, just to point that out right now. So x squared equals 25. Well, that means, if you remember, this is a difference or a sum of squares. In the real numbers, I don't have a solution to this one because I'd have to do a square root of negative 25. So I have no real number zeros here. So let's say this, we have no real number zeros. So we have no vertical asymptotes. So sometimes you just don't have vertical asymptotes because what you have on the bottom cannot ever equal 0. So this can never be 0. So x squared plus 25x cannot be 0. So it doesn't matter what x is, there's nothing I could put in that when I square it comes out to a negative number in the real numbers. All right, so like I said, I'll do a quick graph of each of these. All right, so the first one up here, this was A. So we said that A had a vertical asymptote at positive 3, which we see here. And it should have a hole at 4. So if I go along here and I hit right at 4, we see it's undefined. I actually have a hole there. There we go. Trying to grab the right tool there. So there should really just be a hole in that spot. B, we said that we didn't share a 0 with the top, so both of these zeros at the bottom, we had one at -4 and one at -1. So we should have had two vertical asymptotes, which we see we do have two vertical asymptotes. And they're exactly where we said, one at -4, one at -1. And the last one we said had no vertical asymptotes. And as you can see, it's just really kind of a straight line. Let me kind of rescale my Y here. So it kind of stays in this small area here, but there's no vertical asymptotes.